morning everyone. Here we are going to discuss about few more topics in this hyperperformance computing of Unit 1 related to multi-core and multi-thread processor. In the multi-core, we have Moore's law, which is still validated with the number of resistor getting improved for 2 years once. In this particular multi-core processor with this particular Moore's law, we have few more problems related to increase in the millions of chips. As it is getting larger and larger, we have leakage power and the switching of that particular cores. The main advance and the growth of the cache size alone will not be sufficient to keep this particular Moore's law to be validated. We need a particular performance application to be designed in such a way that we can go with the performance improvement in terms of peak throughput, bandwidth, and etc. In order to compromise and attain this performance, we will be going with the multi-core processor. In this multi-core processor, we will be considering the semiconductor processing technology, which will have a dissipation in the power of the modern CPU reciprocal to the power of the clock frequency. With respect to the clock frequency, we have linear and quadratic power voltage with a power voltage, and we will be having decrease in the linear and the power voltage with the reciprocal of the reciprocal. Now we have a FC and VCC, which is drastically reduce the power dissipation, as we can consider single core with clock frequency and FC of the performance with power dissipation with a clock relative change. Now we will be having a power dissipation which is being calculated with a W of weight with the delta of W with 1 minus epsilon f with PW, which will reduce the possibility of clock frequency, as more than one CPU will be used in the particular processor. Now we have two more comparison with the dual core and the quadra core. In the dual core, we have two processor with 3 level of cache that is added with the data of L1 and L2 and L3. But in the quadra core, we will be having a 4 processor with individual L1 cache with the data with shared L2 with 2 processor, and both the particular dual core and the quadra core will have a shared memory that is being used with the n number of processor. In this separation of cache of the core will have certain levels. With these particular levels, a cache group has been called with a group of cores. Instead, the hexacore will comprises of 6 L1 groups with L2 groups and 1 L3 groups, which comprise the single or the entire circuit. We have a shared cache which is being enabled with a communication between the two cores without relating to the main memory, as it reduces the latency and the improved bandwidth. Now we will be going with the possibility of the bandwidth bottleneck, as it's analyzed the particular performance of the impact of the shared and the cache with I code and independent data. Now we have n number of ASICs that is being considered as multi-core design, which is integrated with the memory control and the memory module, which is attached directly without separating the chipset. So this is a recent multi-core design feature that has been adopted with the particular system, and also we can reduce the main memory latency and also additional socket with the inter-socket network as hyper transport quick path. There exists a particular fast data path between the cache which enables the particular efficiency of the cache coherence communication. Now we have a transit in the absolute necessity of efficient parallel programming. Multicore will reduce gradually into the main memory bandwidth and the cache size availability of the cache. Then we have a effect on the larger cache with the performance with a bond of main memory and also the buffer common memory bus contention. Now we have a complex structure which will be shared and non-shared cache with a multi-core chip which tries to communicate with the cache between two or more cores, and also we will be, and there is a shared cache with two or more cores with the amount of information which is much more faster as the variable gets synchronized with the cache instead of exchanging the data over memory bus. Instead of going with the memory bus with the exchanging of data, we can go with the synchronization of the variable with the cache so that it's much more faster as a certain amount of information being exchanged between two cores. Depending upon the cache and the bandwidth of the performance analysis and efficiency, we have a certain importance of multi-thread or the processor being running on the multi-core. Now we have a multi-thread processor. In this multi-thread processor, we have high performance attenuation of pipelining being inhibit with the usage of dependency, memory latency, insufficient loop, and instruction mix and branch misprediction. Now we have a frequent of pipeline bubbles. In the pipeline bubbles, we have a large execution of resource being remain idle as it is based on the larger latency and the stall delay, longer pipeline, and also we will be having a thread capability with SMT simultaneous multi-thread. Here in this diagram, we will be going with the particular pipelining microprocessor without SMT. Now we have a memory with a L1, L2 cache with an L1 instruction on the data that is travels over to the register and the control which is directly attached with the CPU with the data structure which is lined up with the particular instruction with a multiple instruction set where there will be a execution unit. Now this architecture will try to compromise all the data, status control and everything. We can have this execution resource for unit cache and the interface which is not to be duplicated with the execution of the data. As considering the multiple architecture states, we have several cores that is been attached with the CPU integration where we can go with the multiple instruction streams with a parallelization concept. Filling the bubbles on the pipeline due to the stall in one thread instruction with one another as it is depend upon the previous instruction of that particular thread. We have multiple program which is running parallelly and one thread leaves and one or more them will keep idle with the another thread. Then SMT will have fine-grained switching between the threads that will perform with the pipelining will reduce the particular stall and the latency. Now in this particular pipeline program, fine-grained two-way SMT has been added. Here we will be having a particular memory will L2 with data instruction of L1 register control, but in the execution unit we will be having a particular two-way SMT fine-grained where there will be a switching of data being occurred between two or more instructions in that particular execution unit. But applying this particular new thread support with the pipelining, there will be no more longer stalls will be constructed or been occurred in this particular pipeline microprocessor. SMT will help to increase the throughput and also potentially improvise the instruction being used with multiple threads across or with fine grained two-way SMT. Well, and also it will helps for well optimized floating, and also try to consider the exceptions which have been error that will be thrown with this particular SMT with the pipeline microprocessor. Now we have a performance of single thread which is not improved, so that we will be going with the single instruction stream with hardware thread of SMT enabled. Now with this SMT enabled, we can increase the capacity mesh and also the sensitivity considered on the cache size with multiple threads being used. Now we have SMT which is increased with the cost of synchronization apart from this particular capacity mesh. Now we have hardcore wait for the occurrence of the spin wait loops and also the shared execution content, as this leads to the synchronization of large latency. With this, we will be concluding with SMT enabled with two-way fine grain will be much more efficient, and it will overcome the limitation of the latency and the stall which is there in the previous architecture, which is not been enabled with the SMT. So SMT will be the advantage for overcoming the latency and the stall. As before, we have discussed about the multi-core processing. Yeah, thank you everyone. Here we have discussed about these two concepts of multi-threading processor and multi-core processor. As multi-core processor will have certain limitation that is overcome with the multi-thread processor.